Hey, hello everyone, welcome back. So in this section, we're going to learn how this polling feature works. So we are introducing a new feature in Cardano-node version 8.0, and it is about creating polls, running polls among stake pool operators. We basically want to know the sentiment, the opinion, the thinkings about stake pool operators about a variety of topics. And for that, we are introducing this new feature. This is some sort of an interim feature from now and until we have the full governance features out there. So the first thing that you want to learn is, how to create a poll. And this is perhaps not a mandatory requirement, but it is a good thing to know. It's not mandatory because, it's most likely that you are not going to be creating polls, at least not official polls, as a delegate key holder, right? And the idea here is that IOG, Emurgo, and Cardano Foundation will be able to post these polls online. And the idea is that these polls are made official because they are signed with the delegate keys. The transaction that submits the poll is basically signed with the delegate signing key. That is what makes a poll official. So let's see how CF or IOG or Emurgo would run this kind of polls. We'll create a poll and then how they will give that poll to us as a stake pool operator so that we can then respond to that poll. Okay, so we are introducing a new governance subcommand, which is create poll. And let me just walk you through it. So we have Cardano CLI governance create poll, and you have a number of options as usual. The first option is question. So here you will use the question flag to add a question, right? Something like that. Now, you also have the answer option, and it is because, these polls will have a number of possible answers, possible responses. So here is where CF, Emurgo, or IOG will give us the options that we need to choose about, or we need to choose from. So it is, in this example that I'm creating here, I'm giving you the question, what's the best name for a dog? And the answers we have is Cheeto, Ham, and Rocco. And apologies for that. I just asked my kids which would be a good question, and they told me also which answers to put forward. So this, my kids want to know which is the best name for a dog. Okay, and then we have an out file option as usual. And note that, for example, I will run this thing first without this redirecting to poll.json. Let me show you what's going on here. So I'm going to create this poll. The question is, what's the best name for a dog? We have 3 possible answers and an out file that will be poll.zbor. And the idea here is that when you run this command, it will give you the JSON representation of that question with its possible answers. And you have a couple of hints here. It is use JSON metadata detail schema and metadata JSON file from build or build raw commands. So this is when you are building the transaction to submit this question to the chain. And then a hint number 2 is you can redirect the standard output of this command to a JSON file to capture metadata. And because the delegate key holder that is going to submit this question online will need to use this metadata file that was outlined here, this JSON will be put in a JSON file so that it is a thing that is going to be submitted on chain. So what we need to do here is basically repeat the command, but this time I'm going to redirect the output, as the hint number 2 indicates, to poll.json. And now, if I do a quick ls here, I will have, okay, let me just do something very quickly here. I want to go into example because this is a better place for that. By the way, I am running a local cluster here. I am using the scripts that we have in Cardano-node repository to run this local cluster. I just had to make a couple of tweaks here and there for have it work, but it's out of the scope of this particular video. So let me just repeat this command again. I'm gonna go from here. So I'm going to create the poll zbor and the poll JSON. And I want you to take a look at the poll.zbor. And well, this is the kind of file that will be distributed among stake pool operators so that you can respond to the poll. So apart from it being posted online with a transaction, well, CF, Emurgo, or IOG will be, of course, publicizing this file or giving you access to this file whenever they have a question for you. So that you will need to use this very file, the zbor representation, the serialized representation of the poll. But when they are to publish the transaction with the poll, they will use the JSON file, the one that we created, which is cat_poll.json, which basically just contains the JSON representation of this. So now we are ready to, let's say I am a delegate key holder, so let me just build a transaction so that I can post this transaction online. So the first thing I want to do is to build my transaction, and for that I need to, well, use the build command. And to use the build command, it's very simple. We go for Cardano-CLI transaction build, Babbage era, testnet magic 42, the testnet magic for my local cluster. And here on transaction inputs, I am running all this thing to basically get the UTXO that is going to be used on this transaction. Just to show you, it's going to be something like this. And this is the result of this command. And so it's very practical because this is basically what TXIN takes, right? So it's very simple. The change address will go to whatever address you are using. We need to use this couple of options here. The metadata JSON file, which is the JSON file that we just created a minute ago. And this option, JSON metadata detailed schema, followed by, in this case, required signer hash. We have two options here. We can use required signer or required signer hash. But because delegate keys are on cold storage, the delegate signing keys are in cold storage, well, it is more feasible to use require signer hash, and then you would move this to the cold environment to sign the transaction, and then you will go back. Otherwise, with require signer, you need to reference the signing key itself, which is perhaps not ideal because build requires a live node. And then the output file will be the question TX, a question transaction. So let me just run that for you. And let's see what happens here. It is complaining about something, required hash. Okay, I know what's going on. I am referencing a file that does not exist yet. So let me just fix that. And I will go for Cardano-CLI Genesis key hash. And I think it is verification key file. And the verification key file will be delegate keys and will be delegate one.bkey. And yeah, that works. So let me just now redirect that to delegate. Probably this has an out file option. It should. And the out file will be delegate. Probably it will not recognize that. Let me just see what options we have here. Key hash. No, it doesn't have an out file option. So I will redirect that to delegate keys delegate one.hash. I think I named that. Yes. So now I can do that. So again, let me just go and run the build command. so that this time it should work. There we go. We have a estimated transaction fee of this amount, and right now we are getting ready to sign this transaction. So when we are signing this transaction, note that we are now signing with the delegate one signing key. Again, I am in a local cluster, so if you use scripts Babbage makefiles example, you will find this same the same naming convention. So I am going to produce the question.tx.signed, and I am signing both with the delegate signing key and with the UTXO key to pay for the transaction fee. And now I can inspect my transaction. And this is very useful because you can make sure that the transaction has these required signers. And this must match the delegate key hash. And the witnesses must include the delegate key verification key. To show you, it is cat and delegate one Vicky, and you go from here. So 3F7E, this is the verification key of my delegate key. So that works, that's fine. So with that, I am ready to actually post my transaction online with the usual transaction submit command. I am posting the question.tx signed transaction. And there you go, it is successful. And let me just show you here, I have dbsync running over here, and I can actually come here and have a query. I'm gonna just select everything from transaction metadata where key is 94. Remember that the key 94 will give us the results from the polls that are running. So basically, it will give us all the polls. So we have one poll, and this is the bytes version, this is the JSON version of it, with the options that we proposed, and the transaction ID of our transaction. And together with that, you can also run, for example, something very, of course, you can come up with a more complex query, but I want to show you everything here. So we have on extra keys, this table extra keys now contains this hash, which is the signature of the delegate key, the hash of the signature of the signing key of the delegate that signed this transaction. So this hash will need to be published, made available for everyone to know, so that you as an SPO, when you check whether a poll is official, you can have a list of hashes of signing keys that you can compare these polls online with them, right? So in this case, we know that this is the signing key, the hash of the signing key that posted this question belongs to this delegate signing key. So we are good to answer that question because that's an official poll. So now, next thing that we want to do is to actually create a response as a stake pool operators, right? So let me clear this screen and show you how to answer a poll. So the first thing that you should have, apart from the notice from IOG, Stake, Cardano Foundation, or Emurgo, that there is a poll online that requires your response, well, you will need to have access to the poll CBOR file that we checked before. So you are getting a question about what's the best name for a dog for my kids, okay? So now I can use the Cardano CLI governance answer poll command. This is a new command that we are also introducing with this feature. So we have different options. We have the poll file, answer, and an out file. Very simple, very limited, but it is all what you need. The poll file will be, well, the zipper file that you received from whoever posted the question. And you have two options, basically. Let me just give you the first option, or the interactive option. So let me just run it like this. Cardano-CLI governance answer poll file, and the poll file.json. And it is missing, okay, sorry, this is wrong there. I will need to change that. It is the zipper file, the one that you need to use. So I will update this. So there you go. You have an interactive screen where you can put 0, 1, or 2, depending on your choice. Index 0, index 1, or index 2, and this is what you need to post here. So let me just cancel this. I will be fixing this in a minute so that you don't have to worry about this. But let me for now show you the non-interactive way, which is using the answer option. Well, you would give right away your desired response. So you can go for 0, 1, or 2, and you use --answer with 0, 1, or 2 here to answer the poll. So if, just to show you what's going on here, I can do something like this. What if I say 3, command fail, governance answer poll, or poll answer out of bounds, choices are between 0 and 2. So you cannot give any random response. You need to stick to the number of options that we have available, and we are starting always on base 0, so this is the by index, and well, this is how it goes. So now let me just run the entire thing together, and note that I am this time redirecting the output to poll answer.json. I could also use the out file, which is totally fine, and I can actually do that. Out file poll answer.json, and now I have created cat poll answer.json. This is how my response looks like, and this is the file that we need to include in a transaction to submit our response. And similarly, just as before, we can use the build command. But this time, of course, the required signer will not be the delegate key, but instead the hash of our signing key. In this case, the signing key is the cold signing key. So the required signer hash is nothing else but the pool hexadecimal ID, the pool ID. So let me just actually create this thing, because I'm certainly have not created that yet. So let me just fix that. So it is Cardano-CLI stake pool ID, I guess, and I don't remember. I haven't used this for a while. So it is called verification key file, and it is under pools called 1, I think, big key. And that should give me my output format, make it X, and let me just redirect that to pools pool.hex.id, cat pools pool hex ID, there you go, A17. So this is the thing that I need to put here. This is my pool ID that goes on the require signer hash. So now I can run the entire command again. Let me clear the screen, and it should go really, really good and really simple. Answer TX, there you go. And now you just sign the transaction. This time you sign the transaction with the cold signing key. So of course this would be done on the cold environment that you have for your stake pool. You just bring the answer TX file to your cold environment, sign the transaction, and you produce the answer.tx.sign. In this case, I am signing, of course, with a call signing key and with a payment key for paying for the transaction fees. If I now can inspect my answer.tx and okay, I'm missing something here. TX file. Answer.tx.signed, and you will see that my witnesses include my verification key of my code verification key, and here under require signers you will see the hash of the signing key, which is the pool ID. And now we can simply be sure that we are doing the right thing, and we can now submit our transaction with our response. There you go, transaction submitted, and we can come back to DBSync and see for transactions with metadata. So this is a query on the TX metadata table, and you will see that we now have new field here, a new registry here. This is our response, and of course this is how we know who has answered to that particular question. This is the transaction ID, is the field that links these two tables together. So now with this, the people running the polls can have a simple way to tally this survey and to basically calculate or sum the numbers of responses. Here in particular, this value here is my response 0, so that means I voted for Cheeto. But you can vote for any of the other options, right? Of course. So now, final command that I want to show you is Cardano-CLI governance verify poll. You again have several options: the poll file, which is the CBOR file, and the TX file, which will be the transaction that carried the transaction. Like, for example, this time I'm gonna just grab this from here because I'm giving you the response instead of just using the copy option from there. So Cardano-CLI governance verify poll. The poll file is the poll.cbor, and the TX file is answer.tx.sign, and that will, of course, give the response that we are expecting. That is that there is one response with one signatory, which is stake pool 1 in this case. So this will give you, if there are several responses, it will give you all the stake pools that have responded to this poll. Note that this verify poll will not give you the direction of the vote or the option that they selected. Well, because this is not stored on chain. This is why we are using DBSync, sorry. Well, you will have a very good idea of who has responded to this particular poll. Okay, so this is it, guys. Let me know if you have any questions. Let me know if you want more information about this. Just a final comment from my side. I am running this on a local cluster, and this local cluster is using a few things. So basically, I am using the nano. I think it is a scripts, Babbage, make files. This script is the one that I am running. Just note that this script is currently used by our testing team, and because of that, they are testing Conway integration. So basically what I did is just commented this line so that my cluster does not start in Conway era, but instead starts in Babbage era. And if you want to play around with dbsync, you will also need to make some changes to the configuration file. Let me just tell you what exactly you will need to do. CD example and nano configuration.yaml. So basically you will need to populate the Genesis, the Byron Genesis hash, the Shelly Genesis hash, and the Alonso Genesis hash. And this is because dbsync will complain if you don't have it. Your nodes can start and you can play around with creating polls and submitting answers. But if you want to integrate that with dbsync, dbsync really wants to have the hashes. So you will need to calculate those hashes. The CLI has commands for that. And you need to populate this configuration file so that dbsync can actually pick up. And after that, the only other change that you will need to do is dbsync might complain about the start time. So basically, when you run this script, the start times of on the Byron Genesis and the Shelly Genesis does not match. There's a slight skew, so you will basically need to copy the starting time from the Byron Genesis file to the Shelly Genesis file. And after that, dbsync should just run easily and well. So this is it for today, guys. Thank you very much. I hope this helps. Let me know if you have any questions. See you next time, guys.